You are a doctoral researcher, and you are ready to introduce a completely novel construct into established scientific literature. But the moment that a new variable impacts an existing theoretical framework, you risk an immediate system failure. The core reason for this breakdown is structural. Standard methodologies are highly optimized to measure established variables. They are not designed to define a concept and measure its impact simultaneously. Take an emerging Islamic concept like perceived barakah or spiritual blessing. If you try to force that nascent variable into an existing model alongside established spiritual well-being metrics, the architecture buckles under the ambiguity. Proceeding without a clear plan carries a severe penalty. Examiners will routinely reject your quantitative data if the qualitative definitions anchoring them are structurally unsound. Before collecting a single data point, the researcher must now treat the dissertation as a rigorous engineering challenge. The default trap for graduate students is assuming the phrase mixed methods means executing qualitative and quantitative research simultaneously and with equal weight. Aiming for a perfect 50-50 triangulation approach usually leads to methodological bloat and weak conclusions. The solution to this structural flaw is methodological asymmetry. This requires explicitly designing one method to serve as your dominant objective, while the other serves a strictly subordinate functional role. To execute this, we will map a three-phase blueprint, isolating the literature, weighting the methodologies, and harmonizing the expert data. Establishing a novel variable requires a strictly sequenced asymmetrical architecture, where every chapter is load-bearing for the next. The first foundational pillar of this dissertation blueprint is the systematic literature review, or SLR. The most common structural error researchers make is writing a single monolithic chapter that blends their novel construct with established theories. This diagram illustrates the necessary alternative, bifurcation, splitting that single literature block into two distinct chapters. The specific function of the first chapter is isolation. This isolation chapter must define the novel construct, like perceived barakah, from first principles, entirely independent of the broader study. Once that isolated definition is secure, focus shifts to the integration chapter. Here, you map the overarching theoretical model, such as the theory of planned behavior, to show precisely where the new variable from Chapter 1 docks into the established framework. This exact sequence protects you during the defense. Examiners can validate the theoretical soundness of the new idea before they evaluate how it influences behavior. While a bifurcated SLR builds the theoretical foundation, it relies entirely on the correct asymmetrical weighting of your data collection to prove it. Transitioning into data collection, we have to reiterate that treating qualitative and quantitative methods as equals is a design flaw. This interface displays 5 specific configurations for mixed methods weighting. As a researcher, you must explicitly choose one. Model 1 pairs a comprehensive quantitative survey with a small qualitative interview follow-up, used strictly to explain statistical anomalies. Model 2 is the inverse, a deep theoretical interview study that uses a small survey at the end simply to verify general themes. Then we have Model 3, small qual leading to big quan. This is the optimal path for validating novel constructs. In this model, a focused qualitative group explicitly identifies the issue. That issue is then measured across a statistically significant population by the quantitative survey. Model 4 reverses that order, using a focused quantitative run primarily for case study selection from a broad dataset. Finally, Model 5 represents true triangulation, attempting high-volume data collection in both spheres. This configuration places a significant time and resource cost on a solo doctoral researcher without necessarily yielding a better thesis. The specific weighting you select dictates the entire timeline of the dissertation. For novel constructs, securing a dominant quantitative validation is impossible unless the preceding small qualitative phase is engineered perfectly. Executing that small qual to big quan model requires precise timing, especially within complex multi-criteria decision-making frameworks like the analytic network process. Quantitative models like ANAP will fail outright if the survey variables are based on subjective, untested definitions. This chart shows the critical qualitative tool used to solve this, the focus group discussion. Notice the 3 chaotic data streams representing academic theorists, active industry practitioners, and regulators. You require all 3 of these stakeholders in the room to ensure robust validation. The true function of this focus group is not to host a brainstorming session. It is a mechanism to force consensus among historically conflicting viewpoints. A successful focus group transforms those chaotic opinions into standardized, testable geometric indicators. These harmonized indicators serve as the vital bridge. They are the exact metrics that will populate your broad-scale quantitative survey. The qualitative data functions as a strictly engineered filtration system, ultimately protecting the integrity of the subsequent quantitative analysis. Stepping back from granular data collection, we can observe the complete life cycle of the dissertation. This schematic connects all three phases into a single, unified blueprint. Phase 1 relies on a bifurcated literature review to properly define and dock the novel parameters. Phase 2 requires an asymmetrical methodology, intentionally prioritizing validation over exploration. Phase 3 uses targeted qualitative focus groups to harmonize raw opinions into hard, testable indicators. With these systems correctly aligned, the novel concept moves through the workflow with structural clarity, allowing the researcher to address methodological friction systematically. True academic design abandons the idea of equal methodological weight in favor of functional dependency. Audit your own research proposals and explicitly assign a dominant and a subordinate role to your data collection methods. A dissertation is evaluated just as much on its structural integrity as it is on the findings themselves. Adopting this rigorous blueprint provides the architectural stability required to transform abstract concepts into measurable, defensible science.